Let's review some of the object-oriented terms like classes, methods, objects, properties, and events. These are terms that you'll come across when working in C#. If you've worked with VB.NET or you've worked with Java, these terms are already going to be familiar to you. A class and an object go hand in hand. A class is a template for the object, so it's actually a definition for an object. An object is an instance of the class. So while a class defines an object is a runtime copy of the class. Now there are three characteristics of an object: properties, methods, and events. Properties really represent the data of the object. It's the characteristics. Methods really represent the behavior of the object. These are actions that are performed by the object itself. And events. These are events that occur. For example, shipping a product. Think about events as being broadcast messages that these objects have changed their state. For example, a product has been shipped. That changes the state of the product. Here's a small snippet of code that actually uses some of the terminology that we just talked about: classes, objects, methods, properties, and events. Let's take a look. In this example, I have a class definition. It's called employee. An employee has properties, methods, and events. So a class is actually a user-defined type or definition. You determine the list of properties, methods, and events that make up your class. Remember that properties are characteristics. They describe the object. They also represent data. There's a first name value, last name value, and salary. Here are two methods: hire and promote. These are behaviors of the employee. And here are two events. These events get fired off when these methods occur. Here's my object. I've created an object called EMP, and it's of this type. It represents an employee class. Once I create this object, I can simply access the properties, methods, and events of the class as I'm doing here. So notice I have an object called EMP. It's based on an employee class, and I'm accessing the first name property. And what I'm doing is I'm actually modifying that property. I'm actually assigning it the value of Ed. I can also read a property Here I'm taking the same property, but I'm assigning its value to a variable. So here I'm writing data to the property, and here I'm reading the property value. So don't forget, in general terms, a property stores data about the object. In this case, this property stores information about the employee's first name. The last line of code is just a simple example of how to call a method. Once again, I have an employee object called EMP. I use the dot notation and then the method name and signature. So this is a call to a method called promote. When you call a method, it executes the code that's inside the method itself. A namespace is an organizational tool within the .NET framework. Namespaces allow you to organize classes and other types of information into logical groups. Now in Java, we call these packages. In the .NET world, we call them namespaces. The .NET framework has provided a set of namespaces for its own classes, those classes that come with the .NET framework. Most of the .NET namespaces begin with the word system. Let's take a look. Here are 3 examples of namespaces. When you create a namespace, you've got to give it a name. So the name of this namespace is system. Then we have a namespace called system.io and system.windows.forms. These are 3 examples of namespaces that belong to the .NET framework. Now, a namespace is a way of logically grouping classes together. So, for example, in system.io, you're going to have classes that have to do with I/O, like a file class, or a directory class, or stream classes. In system, I'm going to have some of the more basic classes, like an array class, an app domain class. And in system.windows.forms, that's actually a namespace that contains all of the user interface objects for a Windows application, like a form class, or a button class, or a checkbox class. By doing this, you've kept all of your classes into logical groups so that you can find them a little more readily. Don't forget that when you express a class like form or button or file, the namespace provides the fully qualified name of that class. So we would say the button class is contained in system.windows.forms namespace. Now, one of the really nice reasons for a namespace, other than to keep your classes organized, is naming conflicts. Here's an example of 2 customer classes. There's a customer class that belongs to the XYZ namespace, and there's a customer class that belongs to Abbott.sales. Now, it's very likely that there are 2 companies out there that do create a class with exactly the same name. Well, imagine if one application was using both of these classes, and so they expressed the class this way. The compiler really wouldn't know which class you're talking about. Are you talking about the customer class from this namespace or the customer class from that namespace? So this would be ambiguous. What the compiler actually does is once it knows what class this namespace belongs to, is during compilation it goes in and prefaces all the references to this class with its appropriate namespace. So it's doing that work for you. In an application that uses both of these, this might be ambiguous. So you would need to reference the fully qualified name in order to use both of those classes in an application. So it resolves naming conflicts. Now it's really clear which customer I'm talking about. I'm talking about the customer from the XYZ namespace. The use of namespaces really organizes and categorizes classes into nice, neat little packages. They also provide a fully qualified name for these classes, and they also reduce naming conflicts.